Okay, so here I'm going to talk about the solubility rules, the notes. Okay, so this solubility rules table is used for only double displacement reaction. So double displacement reaction, we know that is 2 in 2, and then you will have compound, compound, and then form compound and compound. Okay, so again, this rule is only used for double displacement. Okay, compound, 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 compound. So you don't need to memorize anything because here you will be given this chart on the quiz on the test, everything. Okay, so the solubility rules is the following. This following, the top part, okay, this top part are the compound containing this. Okay, compound containing this ion, okay, they will be soluble in water. Now soluble, we will use aqueous. So AQ parentheses is the state of the matter. Okay, so aqueous is one of the state of the matter, and so when this is something say soluble in water, we say aqueous, AQ. So for example, if I have something with acetate, that acetate will be soluble in water. Except, if you read the word except, okay? So except if you have iron 3. So for example, iron 3 acetate will be not soluble because this is the exception. So how you're going to read this is, you're going to read acetates are soluble in water except those of Fe3+. So it means if you have Fe3 acetate, then will be insoluble. So all the acetate will be soluble in water except Fe. So the except is the opposite of this. Okay, so except, opposite. So when you see the word except is opposite to the word soluble. So let me give you another example. So all the ammonium soluble in water, okay, that means they're aqueous. So all the bromine are soluble in water except silver plus, Pp2 plus, and mercury 2 plus. It means that all the bromine will be soluble in water. That means they're all aqueous except silver bromide, lead 2 bromide, and mercury 2 bromide. They will be insoluble because the except is opposite to this word. Okay, so all the sulfate are soluble in water except calcium Sr2 plus also. So all the sulfate soluble in water, aqueous, except calcium sulfate, except barium sulfate. This will be insoluble in water, so they're not aqueous. Okay, so the bottom part here, they are the compound insoluble in water. When we say insoluble in water, we say not aqueous. Insoluble, not aqueous. Okay, soluble, aqueous. Insoluble, not aqueous. So what would be the state of the matter? If it's insoluble, not aqueous, it is a solid. They are not soluble. That means they stay as a solid. So the state will be solid. Okay. So just like what we write here, when a compound is soluble in water, it is aqueous, AQ, because they soluble in water, they form ions. When a compound is insoluble in water, it is not aqueous. It could be a solid if it's like a reactant, or it could be a precipitate, PPT, or gas or water if they're on the product. So we will talk about that in a second. So in general, if soluble in water, it is aqueous. Insoluble in water, it is not aqueous. Could be solid, could be precipitate, could be gas, could be water. So when do I know that it is solid? When that compound is on reactant. When do I know it's a precipitate? And it's when that is in product, because they do not form ions. So let me give an example. So all the carbonate are insoluble in water except group 1 and ammonium. So again, this word except is opposite to this term. Okay, so how do you read it? all the carbonate are soluble in water, which means not aqueous, which means solid, except group 1. So, for example, group 1 is potassium. So, potassium carbonate will be opposite, so soluble in water. So, when you see the word except, it's opposite to this. Okay? So, carbonate insoluble in water, not aqueous, except group 1. Or if it's like all the fluoride will be insoluble in water, except group 1 and ammonia. Okay? So we have two terms, one is solid, one is a precipitate. So when do we know we need to write solid and precipitate? Now both solid and precipitate, they are not soluble in water. Okay, so how do I know when do I need to write solid, when do I need to write precipitate? When the compound is insoluble, okay, when the compound is insoluble, when it's a reactant, we use solid because we did not start the reaction yet. We will use solid, okay, compound, okay, we say compound. When the compound is insoluble, but they are in the product, that means they are after reaction, we will use the word precipitate. Okay, so solid, reactant, precipitate will be product, PP. Okay, so I hope that it will help you. So when they're product, insoluble, we will use precipitate because they form the reaction. Okay? So how do I know that the precipitation reaction or double displacement reaction will take place? In order for you to have both, in order for you to have the reaction take place, you need to have both conditions must be met. You cannot only have one of them; they both must be met. So first is both the reactants are aqueous. Okay, both the reactants are aqueous. Why both the reactants are aqueous? Because they need to form ions. They need to form ions for exchange. Okay, if they're aqueous, that means they will soluble in water, right? They're soluble in water. They're soluble in water, that means they're soluble, they separated, they will form ions, then they will exchange a partner. Okay, so both reactants must be aqueous. And the second condition is one of the product must be either a gas or precipitate or water. So the precipitate meaning that insoluble. Okay, so must be a gas, either a gas or insoluble or water. Now here water can be liquid or a gas, either way. Okay, now how do I know that if the precipitation reaction is not taking place? Either case, okay, either case will lead to no reaction. So we go back to here, okay, both reaction must be, both conditions must be met in order for the reaction to take place. Okay, both of them must be present. Here, either one of them happen, then the reaction would not take place. So, first case is either one or both reactant is not aqueous. Okay, we either one or both reactant is not aqueous. Because if they are not aqueous, they are not soluble, insoluble. There are no ions for exchange. They're not soluble. They just settle down. They just sit down. They do nothing. Then they will have no ions. That means they stick together forever. They cannot have ions. They cannot separate it. They cannot have exchange. Okay? So either this or if both the products are aqueous. Both product aqueous, that means they are soluble. Okay? And no gas, no PPT, no water is formed. Means that when you exchange a partner, if all the products are aqueous, that means they're soluble in water again. That means they did not form solid. They did not form PPT. They did not form gas. That means they can be separated again. They are not stable. They are aqueous. They soluble in water. That means they can form ions again. They can exchange a partner again. They did not settle down. So either one of the case will lead the reaction not taking place. Okay. So let's read the example. This is a general example. So we first We recognize that this is a double displacement because we have 2 in 2 and they are compound, 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 compound. So first you have to recognize that this is a double displacement, then you can use this charge. If this is not a double displacement, you cannot use this charge. So you have to first recognize that this is double displacement because the compound, 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 and I have 2 and 2, all right? And then next is I need to write down their state, okay? Once I know that they're double displacement, okay, so you can write the step here. So first, they must be double displacement, okay? And then states of matter. Okay, you need to write states of the matter. Okay, and then third is draw the rainbow exchange. Okay, so you draw the rainbow, exchange a partner. Okay, and then number 4, you will form the compound. Okay. So on the question, you will not be given the product part. You will be only given this part. That's all. Okay, so you will first write down AgNO3, CuSO4, okay? It looks like that I have 2 compound. Then if it's 2 compound, and I tell you that, hey, this is double displacement, you know that, okay, I will need to use this trap. So I find out the state. So silver nitrate, so we look up nitrate. Okay, so nitrate, we go back here. Okay, all the nitrate will be soluble in water. All right, no exception. So that means silver nitrate is aqueous. And then copper sulfate, we find out sulfate. So all the sulfate will be soluble in water except ding, 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 ding. But this exception do not include Cu. That means copper sulfate is soluble in water. So that means it's AQ. Okay, so we will be only given these 2 parts. All right, so after we write down the state, we start to draw the rainbow. Okay, so the outside, right, the 2 things outside, the 2 left, like the Ag and the SO4, we draw 1 red rainbow. And then the 2 inside, we draw another rainbow. Okay, we got to draw rainbow, red and green, right? And then we got it. They start to exchange a partner. So the rainbow here is actually after I exchange. Okay, the Ag does not want to stay with NO3 anymore. Ag want to stay with SO4, and NO3 does not want to stay with Ag anymore. NO3 want to stay with Cu. Okay, now we come up here. We draw the bubble. Okay, we draw a bubble. It doesn't matter which one you go first. Okay, I usually start with the outside first and then the inside next. It doesn't really matter. Now here you need to be very careful. Is when you draw the rainbow, you don't want to write SO4 2 minus first and then Ag1 plus next, because always positive first, negative next. So these 2 will go to the red rainbow. I have to write silver 1 plus first and then SO4 2 minus next. Another rainbow, the green one, again, don't write NO3 minus and then Cu plus. If you write like that, you will cross over wrong. You have to write positive first, negative next. So you have to write Cu2 plus and then NO3 minus. Well, how do you know that the charges? Well, of course, you have to do crossover. You have to do crossover to find out the charges. So AgNO3 will cross over. You know that I got Ag1 plus. NO3 minus, after the crossover, I know NO3 is 1 minus. CuSO4, again, you had to do crossover, okay, to find out the charges. Cu is not plus 1, Cu is 2 plus, because SO4 is 2 minus. You had to do crossover sometime for the Roman numeral. So we write down the bubble like this, and then now here we can form the compound. We do crossover back. We got Ag2SO4, and then Cu, parenthesis, NO3 2. Finally, we go back to find out the state. Okay, so sulfate, we go back to the final sulfate. All the sulfate, SO4 2 minus, are soluble except Ag plus. That means I find the except, that means opposite to soluble, that means AgSO4 is not soluble. Not soluble, and it is a product. Okay, so we use PPT. We do not use solid because this is a product. We use PPT. And then NO3 is always soluble, no exception. So it is always aqueous. All right. And then finally, we can balance the equation. Okay, so finally, we balance the equation. Okay. And those three, the three on the bottom are the all the three cases. So the first one is what we just explained. Okay, the reaction take place, and you need to write down the reason. How do you know the reaction take place? Number one, okay, both reactants are aqueous. Yes, both reactants are aqueous. Number two, one product, Ag2SO4 PPT, is formed. So we have a precipitate form. These two cases must be together in order to form precipitation. Okay, and then the next reaction, we do all the states. Okay, we find all the state, and we find out that no reaction take place. And you see that I don't even balance the equation. No balance. If no reaction, I don't need to balance it. Why there's no reaction? Because none of the product, gas or PPT or water, is formed. You see that they're all aqueous. No gas, PPT, water is formed. And right here, I don't even need to continue to write down the product. I just write no reaction. Okay, I just write no reaction. So let me put a cross here. Let me put a cross here. Okay, this one has no reaction. Why? Because both reactants are not aqueous. They are not aqueous. This one and this one, they are solid. That means that when they sit in the water, they are not soluble. They did not form ions. Okay, they did not form ions. Then so here, no ions are formed. Okay, so no ions are formed, then okay, no reaction. So here I also no balance. I did not balance if no reaction.